So in this case, there actually is a difference between our 7th and our 8th edition textbook. In the 7th edition text, when you get to page 65, over in the margin talking about doing t-tests using a spreadsheet. In that marginal note, they bring up the idea of one-sided t-tests. And they basically say that you use them if there's a bias that means that it should only be one direction. Actually, they don't even bring that up. But they specify they're going to stick with the two-sided t-test, the two-tailed t-test, throughout their book. In the 8th edition, they realized that this is something where students have had a lot of challenge because they're being taught something different in the stats class, and so they wanted to make sure that it matched up more with it. At least that's my interpretation of what they were doing. Now, if you get to page 79 in the 8th edition of the Harris text, you'll actually find a section titled One-Tailed and Two-Tailed Significance Tests. Now let me just talk through that a little bit here because this is something that's traditionally been something I've seen people have a lot of difficulty with here in analytical chemistry. Now, in your equations booklet, I've got the one-sided and two-sided headers, both on our students' t-values. Now suppose that we are imagining that we've done some sort of a measurement and it's got a normal distribution curve that I can't draw terribly well. Now, in one of the earlier videos, I did bring up the idea that we can look at the one-sided and two-sided, but we almost always will choose the two-sided. But there might be some very specific cases where we wouldn't. So suppose that our measurement was for the thickness of a block of wood after it's had 30 seconds of sanding. And we started out with a standard size block of wood, and obviously we're whittling it down by using the sandpaper until it's a smaller piece. So this whole section's been removed. Now we might know something about that sandpaper. And we might know that it tends to always bias things to be even more sanded off. I'm definitely making this one up, but it's okay. We're getting the idea. If we know that we should always end up being shorter, not longer, in the process of the sanding, at least we should always have that bias, then what we need to be considering is only going to be one of the two tails of our normal distribution curve. That's why these values are saying that if we're talking about the 80% confidence interval, we'd go out, let's just say we're going out this far on my curve. I'm probably totally off base on that, but that's okay. You get the idea. Now, if I say that I'm only concerned about one side of that, and I'm saying that it's unlikely to fall in this range at all, then we're saying that the same distribution range should have the same t-value, but with only one direction. That's why the values end up being halved for the residual. So 80 becomes 90, 70 became 85, 50 became 75, because we are getting rid of the other side of that value. That's the basic idea behind a two-tailed or a one-tailed t-test. That said, I'm going to side with my 7th edition text and say we are almost always going to work under the assumption that our methods should produce random data that is not systematically going to be always high or always low. So for our purpose, we will stay with the two-tailed test, and that's how they conclude the description in the 8th edition as well. They say that all t-tests in the book will be two-tailed. And I agree with that. But I wanted you to be aware of the distinction, and I wanted you to have access to the information going into your future careers.